Okay. Good afternoon, everybody. Thank you for being here today. I'm pleased to present you the project Serenity. It's an ambitious initiative aimed at reducing underwater noise during offshore installation. I'm Didier Lasserre from RTE, the French transmission system operator. And for RTE, I'm working at the research department and in charge of the management of this project, Serenity.
And good afternoon, everyone. I'm Gwenael DESSE. I'm the Chief Business Officer at SEALENCE, and in charge of business development activities and partnership.
So what we're going to see during this presentation today. So first we will see why dealing with underwater noise is such an issue for us. And we will present the innovative tool to minimize this noise that we could have during offshore installation. And then we'll see the project by itself, Serenity. And we'll finish with a special call to all of you, the stakeholders, if you are interested to join the project. That will be a pleasure. So we'll talk about this later. So why reducing underwater noise is such a big concern for us? You probably know that reducing underwater noise is a major challenge when it comes to preserving marine biodiversity. Sound is the primary way for marine species to interact with their environment. Underwater ecosystems rely heavily on sound for communication, but also navigation, also finding food and even avoiding predators. When human activities introduce underwater noise, it can disturb the marine fauna. And this is why understanding and managing the underwater sound has become essential for us. In the context of the offshore wind development, and we saw it this morning with the challenging roadmap from the government. So there is this is particularly important during the construction phase, and the main source of noise is the pile driving, where hammer impacts generate intense, impulsive sounds. So there is maybe 2 important points to keep in mind. The deeper the water, the further the sound travels, and the larger the area is potentially concerned. Hence, innovation is necessary. And this is the key to meet these challenges. Alors, why current solutions are not sufficient for us? There is solutions that are existing, like bubble curtains, but they have limitations. They become less efficient when you go deeper in the sea, beyond 50 or 70 meters depth. And it's more and more complex when it's very deep, and it costs a lot to deploy. So at the same time, while alternative anchoring technologies exist, such as suction or drag anchors, driving piles are, however, expected to be widely used on future wind farm installations. And why is that? Is The driven piles are adaptable to many kind of soils, and it's compatible with large scale of offshore developments, and even you have the opportunity to have anchor mutualizations. So the industry faces a clear need, innovative, efficient noise reduction solution adapted to deep water conditions. And that is why we have this project Serenity. And I leave the floor to Gwenael.
Thank you, Didier. So as you understood, underwater noise is a major challenge for all type of foundations, offshore foundation installations. And that's why at SEALENCE we have decided to create the subsequator, a new noise mitigation system to reduce this underwater noise. So the subsequator is a patented system, is based on flexible panels made with an air inflatable membrane. And with this membrane, we are able to create some panels that we link together to create a sort of socks that we put underwater around the foundations during the installations, during the pile driving activities. Once the system is fully deployed, we are able to inflate these panels to create a sort of, to block basically the underwater propagations. So it has been 7 years that we are working on this system, so it's not a new one. But this technology is now developed by SEALENCE and previously by Gwenael. And it's a system that we were able to demonstrate in a representative maritime conditions not too far from here, in Saint-Nazaire Harbor, in 2034. And we were able to deploy a system of 10 meters long and 5 in diameter. And during these trials, we were able to demonstrate all the operational sequences of the system and also the acoustic performances. So one of the key features of this system is really the flexible panels, and that enable us to adapt this system to different type of design and foundations. And this is the objective of the Serenity project. Basically, is to be able to use this subsequator technology and to be able to adapt this system to 2 new offshore foundations. The first one is the pile anchoring or tomorrow use for the floating wind farm. And the second one is the jacket foundations used for the offshore substations and also for the wind turbine. So it's our clear objective is to adapt this system and then to be able to demonstrate the subsequator in real conditions by 2030 during a real offshore demonstration in a commercial offshore substations. So of course, it's an innovative project. So even we reach TRL 6 with our technology, we have to, of course, to meet some new objectives with this Serenity project. The first one is to better understand the acoustic phenomena, the propagation of acoustic, the noise propagations for jacket foundations and deep water foundations. So this is the first objective of the project. Then is to be able to adapt our technology to these 2 new type of foundations with new requirements. And it's not, of course, easy to take this core technology and to adapt to these new requirements with these 2 foundations. And at the end, of course, it's to be able also to meet all our technical changes, to be able to de-risk enough the system to move to an offshore demonstration by 2030. About the technical challenges, so of course we have the first challenge is to adapt our system to deep water depth, better than 70 meter water depth. So it's really more than the bubble curtain limitations around 50 meters. And also we want to have these panels that are our noise mitigation elements that have to be working at deep water depth. And to do this, we plan to have a lab test at 30 bars. It's the equivalent of 300 meters. So it's also a change for us to be able to prove the acoustic efficiency of our system at deep water depth. And then it's two kind of technical changes linked to the requirement to this new type of foundations. The first one, it's the compatibility with the deep pile anchoring, with the chain that will link the floating part of the wind turbine and the anchor piles. So we need to take into account this chain. And also we need to take into account that we have to provide a system that will work completely subsea, that isolate only the pile and not all the water column. So it's really a challenge also for us. And it will be deployed by a floating vessel. So again, it's not exactly the same requirement than the monopile foundations. So it's an ambitious project with some objective and challenges. And of course, the objective and the ambition of the project is to be able to overcome all these challenges and to be able to deploy the system in offshore conditions by 2030.
So, as Gwenael said, there is a technological challenge for this project. We want to bring the new technology from the technology readiness level of 6 to 8 or 9, and this will be achieved particularly with a real-life demonstration of its efficiency during the pile driving of an offshore substation, a rare case. The total budget for Serenity is 14 million euros. And it is co-funded by ADEME, the French Agency for Ecological Transition, via the program France 2030, France 2030. For this project, we have created a consortium with 7 partners, and they represent the whole value chain of the sector. From project owners, project managers, designers, builders, installation operators, such as CDA, Chantier de l'Atlantique, Atlantic Offshore Energy, but also EDF Power Solutions. We have HMC, RMA, Menk, RTE, of course, and SEALENCE and Smulders, which are the 7 partners. We have also other institutional supports, as Mer Méditerranée et Mer Bretagne Atlantique. And we received many letters of support and letters of interest from Eolink, Blue Float, Valorem, Q Energy, and Equinor. So from the environmental impact point of view, the benefits are significant. With Serenity, we aim to deliver a noise reduction between -12 and -30 dBs, depending on the different noise frequencies considered, and up to 99% of reduction in sound exposure for marine mammals. The system also will have a very long and very low energy consumption. It's only, to give a comparison, only 1% of an equivalent bubble curtain. And it induces an important reductions of CO2 emissions also, CO2 footprint. And finally, the system will be a clean technology with no material release and low emission of particles. So this is a major step to one more sustainable offshore construction. So let's look at the roadmap of Serenity.
Indeed, regarding the roadmap of the SEANERGY project, so we have a roadmap until 2030. So the project began in September 2025, and we are now working on the first phase of the project, dedicated to the input data requirements from IRIMA, IRT, EDF Power Solutions and Chantier de l'Atlantique about the adaptation of the design of our system to this new type of foundations. We aim to have a detailed design of our product by 2027. And then we'll start two campaigns of tests. The first one is to, of course, manufacture the first prototype of scale 1 and to demonstrate the system in harbor conditions. So the objective of this test is really to de-risk maximum the system during some operational sequences in maritime conditions. And then to be able to analyze all these results to be able to be ready for the offshore demonstration in a commercial project in 2030 with a real project, with a real deployment in offshore conditions. And then after 2030, of course, we will have some time to analyze the results, both for the operational side and the acoustic performances, because during the offshore test, we will be able to carry out an acoustic campaign with some hydrophones to measure the performances of the subsea quieter. And yes, at the end of the project, we hope to have a system that will reach the TRL 8 or 9. And as you can see, we have also a key objective. It's work package 8. It's also to communicate and disseminate the result of this project for all the stakeholders that could be interested by the topic of underwater noise and by this project. And I will come back later, but we plan to create a stakeholder group associated to this SEANERGY project. And of course, you are welcome to join this stakeholder group. So if we make a focus about the different partners and the contributions to the project, of course, we have some partners that will contribute to the offshore substations test, especially with Chantier de l'Atlantique, Smulders, and IRT that, of course, work on the global level of the project, the detailed design of the jacket infrastructure. Then we have IRIMA marine contractor that will install this jacket, Meng that will provide the hammer, and of course SEALENCE that provides the noise mitigation system. And in the other side, for the floating wind anchor pile, we have EDF Power Solutions that brings their experience for floating wind projects, and also Meng and SEALENCE that will contribute to this to the adaptation of our design to this type of foundations. So as you can see, it's quite a unique project, and we are very happy to have this European consortium with us. It's unique because we bring together all the big players of the entire value chain, and it's of course a very good opportunity to success as a key factor of success for having this offshore demonstration by 2030. Regarding the stakeholder group, as I mentioned, it's one of the key objectives of the project, is really to also be able to share the result and all the learning brings by the SEANERGY project. So we plan to create this stakeholder group that is a group open for all type of actors. So offshore developers, of course, T&I contractor, scientific bodies, equipment providers, engineering company, biodiversity, consulting company, so all the actors that are an interest about underwater noise topic and that wants to be involved in the SEANERGY project. And your interest is also to support the project with some key insights, some feedback about your project, about your knowledge about the topic, and to be sure that at the end, the entire objective of the project meets also your ambitions and your future project. So why joining the SEANERGY stakeholder group First, as I mentioned, you can ensure that our product or design will meet your requirements, meet your future needs about your project. Also provide us some feedback about the design of the product. So we are working on the design now, so you are more than welcome to join the project from now to the end of the project, of course. Of course, you will have some specific access to the result of the project. So we plan to organize or to set up some meetings dedicating with our members of the stakeholder group to share the result and answer your questions. We can also provide some letter of support for your future project if you are interested to integrate the subsequator as a potential solutions to reduce your impact. And of course, you can communicate about the Serenity project as a partner. So of course, more partners will join the stakeholder group, more we can communicate on it, and it's better to move forward.
Okay, so maybe to sum up and conclude for this pitch, we have seen that the Serenity project is about enabling offshore wind development while protecting marine ecosystems. It combines innovation, industrial ambition, and environmental responsibility. By 2030, we aim to deliver a reliable, efficient, and eco-friendly solution for underwater noise reduction, and this even in deep waters. So we remain at your disposal for any further information, and we thank you very much for your attention.
Thank you. I think we can open the... Yeah.